trying to see in the dark in a moonless starlight environment, that's a historic kind of problem that's existed in the military since World War II. So there already is existing frameworks and infrastructure for objectively measuring like how correct is the signal that you're outputting. So we lean on that kind of historic things coming from the military space. Yeah, metricization is a whole rabbit hole, but yeah, in short, it's an AI model that is optimized to reconstruct what's actually there.
Hey, Lucas, thanks a lot for joining me today.
Hey,
Really excited to talk through what's going on at Deepnight.
Yeah, thanks.
Perhaps we can start with just like what does Deepnight do?
Okay. We are solving night vision in a new way. So in short, we've made an AI model that sees in the dark. So we can take any camera and we can basically make it 10 to 100 times more photosensitive. Maybe a more tangible example is for one of our flagship cameras that's very optimized for low light. It's about one inch cubic. You can take that out into the middle of the desert, particularly on a moonless night when there's only ambient starlight, and you can even have a cloud covering that stars. So it's super sparse photons. You won't even be able to see 1 meter ahead of you. It'll just be pitch black. And we found a new way to see in the dark by processing the limited signal from a camera with an AI model in real time and rectifying and inferring the true signal as if it were captured in the middle of a bright day.
Is there actually like some sort of technical heuristic for that? Or, like when you define that anecdote is really interesting, but is it like rooted in something measurable, or is it just like somebody looks at the photo and they're like, oh, that looks like it was taken in the...
Well, you might be asking about like, so there's generative AI that's things like diffusion models or adversarial generative adversarial networks. So those models optimize for making something look like realistic content, like making something look like it's a real thing. We're using the conventional regression approach of machine learning, in which our network is optimized for reconstruction. So it's optimized with supervised learning to restore the accurate information relative to a ground truth. But yeah, there's a lot of ways that we metricize it. So seeing the dark is like trying to see in the dark in a moonless starlight environment. That's a historic kind of problem that's existed in the military since World War II. Yeah. So there already is existing frameworks and infrastructure for objectively measuring like how correct is the signal that you're outputting. So we lean on that kind of historic things coming from the military space. But yeah, there's a lot of metricization is a whole rabbit hole. But yeah, in short, it's an AI model that is optimized to reconstruct what's actually there.
So there is like, it is interesting. There's not just like some sort of like specific signal, but it is like, yeah, like the only heuristic is like, if this scene were lit, what would it look like?
Yeah. So that would be the objective ground truth that you can metricize against, right? Yeah. So for example, like if we're interested in license plate recognition in the dark, you could generate, and you take a picture of a car, you could generate all these fantastic details about a car with a diffusion model, and just generate completely wrong characters for the license plate. It's not objectively correct. And then, yeah, there's a natural objective way to measure the reconstruction, that being you just look at the license plate in a well-lit environment. So yeah, there are ways to quantitatively assess reconstruction, and that's what our model is optimized for.
So maybe take to step you back slightly, like how did you come to this problem? What were you working on before? Maybe take us a little bit through your career and why you decided to work on this.
Okay. Yeah, so I became a founder after working as an engineer in Silicon Valley for 5 years. So I worked at the company formerly known as Facebook in 2019 to 2022. And then I worked at Google from 2022 to 2024 when I started a company in YC or Y Combinator. So during those 5 years in big tech, I was focused on photography and algorithms for photography. So for example, my last job, I was working on the camera application for the Google Pixel smartphone, writing algorithms that go into the camera application and essentially boosting photography performance. So doing things like lens flare removal or making people's skin look more natural or look better. So the algorithms that are used in modern smartphones like iPhone or Google Pixel for your camera are pretty good. They're pretty complex. I think this is that's probably one of the most competed features of smartphones. Like if you ever see like an iPhone billboard, usually the emphasis is on the image quality for the camera. So it was also a super competitive space, which I think
and
yields. Yeah, go ahead.
And the current generation of those, like how much heavy lifting is software doing when I think about how good my iPhone camera is?
If you zoom out a lot, no pun intended, like nobody pulls out, like very few people pull out dedicated compact cameras now. Like 99.9% of photos are taken on smartphones, but the size of a lens or the size of the optic is like less than that of a nickel. So like there has to be something compensating for the really small optics in phones, and yeah, it's the algorithms that are doing the heavy lifting there. But that's what's driving like insane adoption of smartphone photography. It's what almost all photos are taken on now these are right now.
Yeah, I mean, because I don't know, it's kind of nuts because I have like relatively nice cameras, but it's still like there's a sense that like I'm not like in a lot of contexts I'm just not going to get better results than my phone.
Yeah, like you might have a DSLR and it will get higher resolution photos than your phone, but I imagine you might be so close to the point of diminishing returns there that in most scenarios or all scenarios, it's better just to leave your DSLR in the closet.
Yeah.
And you just have your phone in your pocket.
Or the phone just does what you want, right? Because it's like, you know, you have to very like heavily control the DSLR for stuff like depth of field, where like phones like make a bunch of assumptions about the scene and what you're looking at, and like just take kind of the right picture in a sense.
Yeah, it's point and shoot, and you have technology making them more usable.
Multiple lenses.
You have complex auto exposure, especially. I'm not sure about iPhone, but for Google Pixel, the auto exposure is very complex, and in the majority of circumstances, I think it'll do better than a manual exposure that you have on your DSLR if you're not if you're not like really diving deep into photography.
Yeah.
Yeah.
And so at Google, you were working on these types of algorithms primarily, or like what was the, you know, maybe like talk a second about your work there.
Yeah. So for Google, I shipped features in the camera app for the Google Pixel 7 and Google Pixel 8. So we had a yearly release cycle. So which is actually really, which is pretty difficult because you have to, I was making AI based features. So I'd have to do the research on creating the neural network, training it, optimizing it, deploying it, and making that into a product and then testing it all within a yearly release cycle, which is pretty difficult. But yeah, it was, I would say that the focus of my work was on device AI. And this is, most of this is before AI became associated with these extremely large server side models like ChatGPT, where they're running on a gigantic data center. So my focus was AI that runs directly on the phone in limited compute for something that's like very practical, like a very practical value for the user. So maybe one example is if you do take a picture with Google Pixel and there's a lens flare, you will have AI generated pixels in that photo, and there's no opt-in, there's no information. Like people don't even notice it. It's just that natural and seamless that there are AI generated pixels covering up the lens flare, and you don't even know about it.
And when you how much of what is going on in my smartphone is like a neural net as opposed to some sort of like procedural fixing of an image? And like, did you see, like, were you party to that transition? Like,
definitely party to that transition, and it's going to depend on which one you have. I think probably the most egregious ones would be something like Huawei, where if you take a picture of a phone, if you take a picture of the moon and it's low res, they'll literally AI generate or in-paint a high resolution moon in front of you.
So like at the limit, it's like can be just entirely generative.
Yeah.
All right.
Yeah, and so for Google Pixel, I would say as far as I know, my feature was the first fully generative feature that was added for Google Pixel by default. That being for lens flare removal. So yeah, I think a lot of consumers don't like this, but the natural transition is more like your photography is going to be more and more AI generated. I mean, it's kind of like CGI in cinema. So there's always going to be this crowd of people complaining about it, and maybe rightfully so. But yeah, for the most part, people love these Marvel movies.
Yeah, totally.
Yeah.
And I mean, it's like you want your picture to look good. So like the
Yeah.
perception is kind of the reality in some weird way about like a lot of these technologies from a UX perspective.
Well, I mean, like like there's this. I'm not a super big like Marvel movie consumer, but like I know there's this crowd of people that are complaining about like CGI Groot and all of these animated characters, but just objectively, those are very successful franchises. So similarly, like a lot of people, maybe like if you survey them, if you have them do a written survey, like do you want more AI in your smartphone photography? Maybe they'll say no on the survey, but in terms of consumer choices, like what kind of phone they buy, yeah, the natural trend is going towards more AI getting inserted into what's coming out of your camera.
Because your perception of whether or not it looks good, I don't know. I mean, we get into some sort of philosophical argument of the point of photography and memories or something like that. But all right, so in this backdrop, you had like, were you working on, were you working on low light photography in that context, or like you just like it was adjacent to what you were thinking about? Like, how did you come to that specifically?
Yeah, I wasn't particularly working on low light at Google. There was a couple engineers that were focused on that. Not really tackling it from an AI perspective, more of a classical perspective. So there is a pretty renowned scientist, Mark Lavoie, who has done some pretty notable work on low light photography for Google Pixel. So that's something that a lot of people check out. It's kind of famous within the computational photography ecosystem. So yeah, it's something that was, I would say, adjacent
and that's neural net based.
Currently, it's as of 2024, it was not neural net based. Yeah, I imagine that they are trying to make it neural net based maybe right now. That seems to be the natural transition for pushing computational based imaging to the limits. I mean, that's what we have to do in our case, because we are tackling such extreme photon sparse environments, and just the state of the art algorithm right now is things like gradient descent neural networks.
And then, so when was the moment when you realized you like that this was possible and you wanted to go build it?
Well, I wouldn't say that I didn't realize it was possible until we did it. Well, in terms of the North Star that we're chasing, so what we're tasked with at Deepnight is we have to beat the incumbent technology for seeing in the dark, that being the analog image intensifiers. So this is a technology that is used by the military since World War II, since the invention of night vision. It is not camera based. It's not computational. It's not even digital in any regard. It's the analog image intensifier in which light comes in. There's an analog process, and then more light comes out. It's a completely different vertical from how we operate.
Like it just has something internal in it that projects more light on the images.
Yeah. So, and it's not my field, but the general way that it works is the photons will get converted. So photons will go through the tube. They get converted into electrons. There is a electron multiplication process, and then the electrons get reconverted back into photons, and that's your output. So it's essentially a photon multiplier. And at no point do the photons get represented as a digital signal. So it's a completely different way from how we operate. But that is our North Star in terms of what we're competing against. So I would say that we didn't realize that it was possible to replace this with cameras and AI until we have that in a real world side by side. And that happened, that took about probably 8 months within Deepnight's formation. So.
But you decided up front that was what you wanted to work towards. You kind of had this intuition that a neural net could probably do this better. No one's actually thrown the right amount of data at it, and let's do it and see if it works. Yeah,
no one has tried to solve the military grade night vision problem through neural networks. So yeah, I would say that at the start of the company there was hard technical risk, where there was a question as to whether we would even succeed or whether it'd even be possible.
And the V1 is just like a neural net running on a computer.
Yeah, the V1 would be
Like you're not really you didn't start resource constrained.
Yeah. So yeah, the V1 would be you get a NVIDIA 4090 desktop workstation and you run something in real time. Actually, the V0 would be you don't even have a real world demo of it streaming in real time. You just get infinite amount of time and you just generate an offline video. So that's a V0. But that's what we could do feasibility analysis on.
Yeah. Because the constraints are both processing time and hardware, basically.
Yeah, the constraints are physics, how like the raw amount of photons that your camera can acquire. Physics, how good the AI space is just in general, like whether we've invented transformers versus convolution, just the sort of the abstract intellectual aspect of AI, and how fast computers are. Yeah.
Okay. And there's an interplay between them because more physics means faster. You need a faster computer, effectively. Like more photons means you need more processing power.
I wouldn't say that. Yeah. So our model will run irrespective of the amount of photons coming in.
Okay.
Yeah.
Was that important from the onset? And because you're like, we can't really predict what kind of camera or what kind of sensor is going to be used.
Yeah, I would say, well, we came in not with that. We came in not with a full appreciation or understanding of the constraints, I would say. So there has to be some level of, I think there has to be some level of leap of faith, because it's not like we were, like maybe a more conventional way to start Deepnight would be, you're a scientist at SRI International, and then you're working on cameras and you're developing a really strong understanding of the limitations of where cameras are at, and then you get the opportunity to spin out. We started in Y Combinator, myself and my co-founder. So no resource besides 500K of capital. But yeah, we didn't have partnerships with camera OEMs lined up, or we didn't have like partnerships with AI compute companies like Qualcomm lined up. So maybe a better way to start the company would be like starting with a full appreciation of where the problem's at in hand to start with, and having all the relations lined up. So yeah, we did start from scratch in that regard. But
so for did you go through YC 8 months in, like after you had a result, or did you just?
No, yeah. So we started in YC without any feasibility work on.
Okay.
Yeah. So with no appreciation of where the state of the art currently lies, and like and how far away the state of the art in cameras is from image intensifier quality.
And so you picked a problem, quit your job, and applied to YC, basically. More or less.
Yes.
Okay. Do you think you would have done it differently now that you have an appreciation of the difficulty involved?
Yeah, well, I would say that, probably the ideal way, like the optimal way to start the company with the least risk posed to yourself would be you're already working as a scientist on cameras at like a firm like SRI International, and you have a full understanding of where cameras at, or like quantitatively how far the gap is between cameras and image intensifiers. That would be the best way to start the company.
Okay.
Yeah.
But it might also be true that like diving into the deep end helped you not, like that kind of person might also be like, oh no, they might shy away from the problem. Yeah.
Well, we have pretty good friendships with the people that work on cameras that are intended for extreme low light sensing. And they tend to be very, very experienced, like very late into their career to be the person that's a director within a company, working on research for cameras. And I would say that like the demographics of that crowd don't align too well with the demographics of people that are starting companies currently, or starting AI companies currently.
Yeah, I mean, there's a common thing of just kind of like younger people start startups because they don't know what they're getting into, or the depth of like how hard it can be. Wait, and so all right, so you got it working in the general case. You just got a model that worked. And then you started looking at like, what does it actually look like to operationalize, or, and like can like work with the constraints of the devices on which it might need to run. At that point, did you feel like you had your head around how hard that would be, or was it like a novel, like unbounded problem?
Well, something that's interesting is like, let's say if right now only the V0 is working, where we still need an infinite amount of time to process. We need a huge, gigantic model to process to get to the point where we have image intensifier parity. Like something that I think about is like, we would be guaranteed to win no matter what. It's just a question of when, just because of the way Moore's law progresses, right? I see our company as being leveraged off of Moore's law, and I can just ride that wave, and eventually we'll succeed. So even if we aren't replacing image intensifiers now, it is guaranteed that soldiers will be seeing in the dark through neural networks at some point in the future. That is easily a guarantee. And it might not happen. I want it to happen as soon as possible. But yeah, in the worst case scenario, it'll take until say 2050. But it will happen eventually, just due to the progression of AI compute. And the analog technology does not progress. Like there's no, I don't see like a version 3.5 of the record player coming out next year that I'm really looking forward to, right? But it's just analog technology just doesn't progress very well.
Yeah. All right. And then maybe talk like what are the hard constraints of getting from, just having the best possible model to a model that works? What context does it need to work in, and like what duress are you under?
So we target mobile computers that are small enough to be head worn or used in head worn applications. So that tends to be SoCs, so things like Qualcomm processors, Halo, Umbrella, those SoCs, or particularly the neural processing units on SoCs, systems on chips, is what we're optimizing for.
Mm-hmm. And are those, like, how did those relate to like the size of model you had running on a computer?
Yeah, so the V1 would be gaming workstation. It's still a 60 frames per second demo, but it's on a gaming workstation, like a 4090. And then an SoC, that's the same amount of compute that you have in a smartphone, which is why this company relates a lot to my background. So SoCs, they're commonly used in just about every smartphone. And we basically need to, we were basically tasked with taking this model that runs in real time at 60 frames per second on a gaming workstation, getting that working on the same amount of compute that you have on a smartphone. I'm off the top of my head, I'm not exactly sure what the order of magnitude of compute in terms of sort of like floating point operations. It would be something, I've already guessed it'd be something like 50x or something like that.
Okay. And were you immediately, like, how did you dive into that problem being with confidence, or were you kind of like, this is another experiment, we're going to see where we can get?
I would say with confidence, because so starting out the company, maybe I'm not an expert on the physics of cameras or the state of the art in low light cameras. But my entire 5-year career prior to that was on optimizing AI for mobile devices. So that was the aspect I was very comfortable on. No, so that's where I would feel like that's why I felt.
So in the shape of the company broadly, you kind of felt like if we get it working on the gaming console, then it will work, and we can figure it out on the phone.
Yeah, that's what I'm all about. Yeah.
Okay. And what are the hard, what do you actually have to do? What are the hardest parts of that?
So yeah, we do every operation that we run is quantized. So it's all the mathematics is using 4-bit or 8-bit integer precision. And then there's the more abstract intellectual aspect of AI. So what neural network architecture has the most representational capacity with the least number of operations. So we've done a lot of novel work there. We've made our own neural network architecture from scratch. So we're not just copy pasting open source models that are already out there. We had to make something from scratch that's directly optimized for the hardware that we're targeting. Yeah. So yeah, so there's some general things like quantization, knowledge distillation. So that's when you have a student network that's very small. You essentially learn from a teacher network that it has unbounded compute. And then the major thing that we did is make our own neural network architecture, which is a much more abstract or intellectual thing. Try to fit as much representational capacity in as little operations as possible.
Explain quantization briefly.
Yeah. Well, like if I ask you like what's 3.72 times 5.89, and you just try to do that like mental math in your head, it'll take you maybe like a minute or something. But if you know, like if I ask like what's 3 times 5, you'll just say 15. Like it means instantly. So that's actually a pretty good proxy for what operations are also fast on computers. They're much faster at integer math than floating point math. So all of the mathematics that are running when we're running our neural network is running with integer operations.
And is that and is there like heavy risk of losing quality of model?
Yeah. So you lose precision. You're sacrificing precision for speed. And then we do things like quantization aware training, in which the model the imprecision is simulated during the model's training, and so the neural network has to learn to adapt to that imprecision and compensate for it. But yeah, that is the most effective way to make a neural network run fast. It's not specific to our problem. It's now being very commonly used in large language models now as well.
Wait, what is the relationship between quantization and distillation?
Distillation. So yeah, this is another thing that's not necessarily specific to Deepnight's problem. So if you the way that we optimize our model is that we do supervised learning, in which the prediction is graded against a known ground truth. So this is like saying the loss function is the difference between the predicted license plate and the ground truth license plate that you capture in the middle of the daytime. So that's the standard loss function. In knowledge distillation, the loss function is you take the student model, which is your compute limited model with a small amount of operations, and the loss function for that model is the difference between the student model's prediction and not the ground truth, but actually the teacher model's prediction. Yeah. So it's for a variety of reasons that is a easier way to learn for a student model than learning from the ground truth.
Yeah. And did you have to do this? Like it's for like you're doing it for the specific architecture of the system on a chip for the device you're targeting. Is it like per device that you're having to train the new sub model?
Yeah, we optimize different architectures depending on the hardware as well. So we have different variants of our architecture based on what target hardware platform we're targeting. Because some operations might be faster on a particular SoC versus another.
And then are there additional constraints based on the use case of like, what a human can watch on video without it being, there's a performance characteristic of it that is like perceptive.
Oh, right. So we do optimize for correctness above all else, because we target things that are like safety critical applications. We're very interested in automotive, and then the military is exactly the kind of application where you would want correctness rather than perceptual quality. So for the most part, we always optimize for correctness over perception when there is a trade-off, I would say.
Were there any points in this process where you like hit a wall you weren't really sure you're going to be able to get through?
So at some point we are battling against physics. So we have solved Moonless Starlight imaging on like a 1H cubic camera that's flagship, and it's custom designed for Moonless Starlight imaging. So it's from the ground up. There's hardware software co-design between Deepnight and that camera. It's the full package is from the ground up meant for seeing in the darkest possible condition.
Like as good as it can be.
Yeah, as good as possible. Yeah. And it's using a very good NPU. So using a Qualcomm NPU. I want this to be so that is a pretty good solution, and we have a really good company just doing things like that. But to deliver the maximum possible value, I would say to humanity, I want to democratize this to seeing in the darkest possible conditions, but also for smaller and more commoditizable sensors. So I wouldn't classify the camera that we have that running on as being a commodity camera or a particularly super mass producible camera. So something that I think about is we use CMOS sensors. That's the image sensor that we run on. There's 40 billion CMOS sensors in the world. So like just in this phone, right? I have there's like 5 right here. Yeah. So that's actually a pretty good representation of the ratio. There's 8 billion people, 40 billion CMOS sensors. For applications like Ukraine, Ukraine procured 1 million small drones in 2024. It's an unsolved problem. How are you going to make 1 million platforms produced in a year, all see in the dark with a military grade night vision capability? That's currently unsolved. And with that flagship camera, we're not solving that yet. So we need to figure out how we can move to smaller and smaller and particularly super commoditized sensors. Plugging more into that 40 billion kind of scale. The purpose of Deepnight is to democratize night vision as much as possible.
Yeah. How do you balance? I mean, it gets back to what you said earlier, that there's a little bit of a bet on Moore's law behind this. With so like there's a balance between like time is on your side in terms of the fundamental hardware, but also like you're going to deliver the most impact to the world if you work on the hardware everyone already has in their pocket. And like, is this just like trial and error and see what you can make work, or do you actually like develop like pretty heavy intuitions about where to spend time and effort and like or is it, I guess it's is this more art to science? Like you just keep iterating and try the next logical thing, or you've gotten like a very heavy intuition about what you can make work?
Yeah, well, so the power of computers is changing, but the physics doesn't change, right? So the amount of photons that ambient starlight will be emitting that radiate all the way to the Earth's surface, that is always going to be like a fixed constant. And so, yeah, I do see ourselves as battling against physics, where if we are using these truly commodity sensors, they're only getting photon counts per pixel per exposure that are sub 10, so like single digit photon counts. And so you're trying to recreate a picture of the world based off of for each pixel you just get okay, that's 1 photon, that's 2 photons, and there's like extreme noise going in there.
Which sounds kind of impossible. Phrase it that way.
Yeah. So we don't have Moonless Starlight sensing solved on a real time system right now. But something I think about is that the gap in floating point operations between ChatGPT, like a server side model, versus what we're running right now in real time, it's like 10,000x number of operations. And so eventually, and this is what companies like Qualcomm this is the picture that companies like Qualcomm are trying to go for. There will be a scenario in which you have ChatGPT sized models running locally on your phone. People are trying to, like, there's hobbyists trying to get this working right now. But like ChatGPT running really fast in real time on your phone. So I'm wondering what the world would look like if we had a Llama 7 billion sized vision model running in real time, processing such a limited stream. And so I would say it's an open question. If you take the limit of massive model size versus extremely difficult physics kind of problem.
Yeah, but it's actually a practical question for you. You have to, you have like R&D that you're doing tomorrow, and you decide whether to build for like the reality of hardware, like position the company for the reality of hardware in a few years, or try to get further on what exists today.
Yeah. So we are a seed stage company. So we have to build the company incrementally. It's not like we're starting out. I mean, there's people. Maybe this is like there's people like the ex-CTO of OpenAI that get to start out with $2 billion. But and I don't get to start out like with $2 billion. So I can't do anything. I can't do anything crazy like trying to change where hardware is at, or change the today's limitations of hardware. So yeah, we have to build a company incrementally and just focus on making money with what's currently out there. Yeah.
What do you learn about the market, and like have Has talking to like the most likely customers heavily informed where you had has that been actually more of the decision than your assessment of the technical difficulty?
So talking with the customers talking to customers for getting assessment of the technical difficulty.
No, like when you think about like how do you prioritize R&D, is it like just heavily rooted in who is actually most interested in this?
Oh, okay.
And what hardware they have.
Yeah. So we focus on things. We focus on things that are already out there. That's the priority. Like we don't, at the stage that we're at, we don't have a single Deepnight system that's deployed to military users in a real end user application currently. So we're building the company incrementally. We're prioritizing short-term wins. So the sole focus is getting this technology in the hands of real military users, and that's going to be on whatever compute platforms that they have access to right now. But there are right now in used by SOCOM or Special Forces quite a bit. There are these Qualcomm enabled or SoC based drones that they're using. So that's the kind of platform that we're immediately targeting. Just what kind of computers are actively out there, what kind of compute-enabled soldier-borne systems are out there immediately, and that's what we're targeting.
Have you run into any customers that like where it was like hard, like have you run into contexts where there was more demand but the compute constraints were harder than expected?
Yeah, well, I mean, this is the whole Internet of Things thing where if I just wait like 2 years, like let's say they don't have an SoC based system. Actually, maybe let's take security cameras for example. Maybe a precursor to Verkada would be Bosch, right? Maybe a Bosch security camera in 2019 might not be SoC based. It might not have an NPU, but you just wait until 2025, and now Verkada comes along, and they're all SoC based, and that could be an application for Deepnight. So there are there's so many immediate things in the market right now that have SoCs that are capable of running Deepnight algorithms, and we're targeting that. And if not, I just know in 2 years they'll be upgrading to something that's SoC based. Like everything's gonna be able to run AI in the future. Like you're gonna have, it's like your smart refrigerator is gonna be AI enabled in 2030, right?
Yeah, the cat's out of the bag. It's like AI. It won't be AI anymore. It'll just be kind of compute.
Yeah,
everywhere.
Yeah. Everything is computer.
Yeah, it's all the way down. I feel like there's a broader trend, right? Like, you know, specifically in your journey from like writing, like watching it happen on smartphones, but it's just like, I don't know.
Yeah, well,
neural nets are better with enough data. Neural nets are better at things.
Yeah, like I don't even think
that people can reason about.
Yeah, I don't think there was a chief visionary saying we're going to reinvent cameras where it's going to be the combination of a computer capable of running AI and a camera. I don't think there was ever a chief visionary. It just naturally happened where you put cameras on flip phones and then flip phones upgrade to SoCs, and then like naturally magic happens.
Yeah. Because there's a history of like just refining optics and getting better at making glass, and then suddenly someone's like, "Well, there's a shortcut."
Yeah, I think the addition of SoCs into smartphones, that would be for things maybe like better networking features, like having 5G, or just having like better display, like better rendering. So the resource that compute resource was added to smartphones, I would say more naturally, not explicitly for making the photography better, but then you basically have all these engineers in a room saying, okay, I have a system where it has a cheap camera, but I have all this compute, and now it naturally happens. Now you're naturally making that AI enabled camera. So yeah, maybe like similar things will happen for your smart refrigerator with an SoC.
Do you have predictions? Like what's going to happen to smartphones? Is there a lot? Are there more surprises from here in terms of like what else can be running through a neural net to make even just like cameras better?
For cameras or more generally?
Either would be interesting, but I guess cameras is.
Yeah. Well, I think that there could be an application for a local AI. So I think I'm not super familiar. There might have been a company called like Humane Pin, or I think Humane Pin was trying to work on this, where they would have a local model running within the device, or actually, I'm not sure if they had it local. I might have.
No,
Yeah,
it was. I think
yeah.
there was a bunch of latency, which
Yeah.
is why the demo was kind of.
Yeah, but I'm sure there will be startups in the future that are trying to get AI models, like maybe like a personal AI assistant, but it runs locally, so there's low latency. So there's gonna be a lot of companies like that, and they will be faced with similar challenges to Deepnight, where they have to get AI run really, really fast on mobile computers. That's the technical challenge that I'm most interested in is the efficiency challenge. And yeah, but right now, I think the most immediate kind of application for that kind of challenge, or at least for me, was for night vision.
Yeah, that's interesting. But you just have this general intuition that whatever we can get working, eventually we're going to be able to get working on devices we carry around, and that's going to change a lot of context. And certainly, like, I don't know, there's a lot of obviously like all the privacy and
yeah. This is not really even my talking point or my kind of hill to die on. This is more of something that Qualcomm and Apple are really interested in.
Mm-hmm. Yeah, that makes sense. Maybe switching gears slightly. Do you guys like? I mean, at Deepnight, like, how big is the team, and like how many people are writing software these days?
Yeah, so 10 people, and then 8 are engineers. So we have whenever we hire someone, there's a particular role to fill. So I mean, like if you're a big tech company, you just hire software engineers and you try to retroactively fit them into some team. But yeah, for startups, there's a particular portion of the company that you want them to complement, right? So I would say that we have a split of people that are really research focused. So we hired them based off of academic publications that are relevant, and then we have other people that are more implementation focused, getting this deployed into a product end to end. So we also have like ex firmware engineers from Qualcomm that just handle maybe the less marketable things, like the sensor driver between a camera and a Qualcomm board, like that interface. But yeah, we're handling the full stack of AI, from the intellectual and abstract research of AI to deploying that end to end into a device.
And then, like, as a group of people who have like fairly fundamental competency in things like neural nets, like, but also at the same time are like a little bit the more esoteric end of like writing software. Like, how much are you using LLMs to write software yourselves internally?
Yeah, I believe everyone at Deepnight uses Cursor. I don't mandate this, but everyone uses Cursor, I think. I certainly use Cursor. Yeah, it's just the meta for engineering or doing anything intellectual. It is yeah, no, I think people are rightfully concerned to fear AI replacing everybody. Like, yeah,
Has it changed your workflow? Like,
yeah, no,
heavily?
Yeah, very, very heavily. Yeah, yeah. So anything low level, I just don't do anymore. So I would say that, like, for the most part, my programming language is just English now. For like 80% of the code that I write, is English directly. It's like only 20% of the code I write is directly programmed.
Yeah. Do you still spend a lot of time reading the result then, or like how do you feel like you're going to lose fluency on the underlying at some point?
Yeah, I think I will. I think everybody will. Like, I think it's like I can't like. Yeah, I think people are gonna forget like what a template function is in C++. Like, they'll just let AI handle it. I'm not sure if that's a good thing or a bad thing. Maybe I'm not particularly opinionated. Like, I don't use physical maps. I don't even know like if I don't have Google Maps, I just don't. I don't know San Francisco at all. I don't know the geography at all. I'm just like an NPC. I just let the thing route me, right? And so, like, maybe like my parents will say, "Oh, that's clearly a bad thing. Like, what are you gonna do in an apocalyptic scenario?" But from my perspective, it's awesome. Like, it's great. Like, I just don't think about the roads. I just
buy in.
I just let it navigate me.
Yeah.
Honestly, it depends on. I guess it depends on who you ask whether that's a good thing or a bad thing. But that's what's going to happen essentially for coding.
Yeah. Well, I mean, it's happened at different levels before, right?
Yeah.
Like, obviously, I don't know assembly.
You don't know how to make a fire. I mean, do you know how to make a fire? Or do you just use a stove?
Like a fire, like from scratch?
Like, you just use a stove, right? It's kind of like that.
Yeah. I have a mild intuition, but I'd probably take a lot of trial and error if ever it was successful. But That's an interesting question. It's weird, and it's weird. Like, at what level of abstraction is this a problem, and when should you just lean into it? Is like kind of I guess, a broad societal thing.
Yeah. So like people will be like, I have friends that like ask me like, okay, what would you do if there was like an EMP event and there was no electricity? And I just, I probably would not fare the best, like compared to other people that are more off the grid. But that's just a trade-off that I make personally. And similarly, like, what would I do for programming if I lost access to Cursor or ChatGPT? I wouldn't fare. I would probably fare poorly compared to people not. But it's just a trade-off that we make.
But the fire analogy points out the fact that it's a spot on a continuum. You know, it's not that like people like to pretend as if there's some discrete drop off and no longer understanding C++ templates. But you know, it's more of a fuzzier.
I mean, like we're essentially moving from lower level programming to higher level programming, like once again. So like maybe like 15 years ago, everybody's using C++, but then there would be that one guy in the corner that say like, well, like what would you do if we didn't have object-oriented programming? We had to use C, right? So maybe people that are my age right now in the future, when we're working with like 20-year-old college graduates and people like me are 40, like we'll be saying like, what would you do if you didn't have ChatGPT and you actually had to write code? Like, do you even know how to write code? Like maybe like, I think there will also be software engineers 20 years from now that just literally don't know how to write code. It's quite possible.
Yeah, it's really weird. I think, and it's like identity piercing, because I know like early in my career I could kind of, you know, actually think through the tokens in my head and then type them out in separate steps. But it's, why is that important? I think there's this broader lesson of kind of like neural nets generally, where you're like they're better at things than human reasoning with enough data.
Yep.
Yeah, and it's like a little bit scary and disorienting, but once you like kind of buy into it, it's hard to deny.
Yeah, well, so we're doing a task similar to denoising for Deepnight, and so if you deliver the raw feed of imagery that's super noisy to a human, the human brain has its own data-driven denoising to kind of infer what's there. So the human brain already has this neural network based.
Like you can walk around in the dark.
Yeah. And that is, in a literal sense, that is neural network based.
Yeah.
And ours is just better than the human brains actually. So we test this out. Like we have people, because if you look at the input in a real time stream, let your brain try to denoise it, and then let our AI model try to denoise it. Ours is just better. And yeah, I think that's a kind of a general principle. So there's a lot of other domains in which neural networks, or artificial neural networks, are better than the natural neural networks.
Sweet. All right. Well, ours is better than the human brain. I think we can like leave it there. That seems like a fairly good stopping point. What should we look forward to from Deepnight?
Yes. So very soon we will be in the hands of real military users, and there will be the first instances of people seeing in the dark through a neural network for real military operations. That will happen very soon. That will happen in 2026. I would say that's the number one thing that I'm focused on. So I think that's the only thing to look forward to, really.
Awesome. Well, great. Thanks a lot for the conversation. It's been a lot of fun.
Yeah, thanks a lot, Brett.
All right.